Hi everybody. Up to this point we've learned about major and minor intervals, and now I want to teach you about perfect intervals. So the first thing you want to know about perfect intervals is that the unison, the octave, the fourth, and the fifth are the intervals that can be perfect. Because we already studied that seconds, thirds, sixths, and sevenths can be major or minor. Unlike those, the unison, which we would denote with a number 1, the octave we denote with a number 8, fourths and fifths are perfect. We denote the quality perfect with a capital P. We have a different system for perfect intervals, and this goes back ages since the 4th century BCE through treatises by the ancient Greeks like Aristoxenus and Ptolemy. They came up with these systems originally, and the reason why they consider the unison, the octave, the fourth, and the fifth perfect rather than major or minor is because of the ratio of the frequencies of the intervals. For example, the unison has a ratio of 1 to 1. It's the same note. The perfect octave has a ratio of 2 to 1, meaning the higher note has double the frequency as the lower note. The perfect fifth has a ratio of 3 to 2, and the perfect fourth has a ratio of 4 to 3. Now, you don't need to know all that or remember all of that. But we do have this different classification for called perfect for the unison, octave, fourth, and fifth. And you do need to remember that unisons, octaves, fourths, and fifths all fall into the perfect category. We could never label an octave or a fourth, for example, major or minor. They could only be labeled as perfect. Likewise, seconds, thirds, sixths, and sevenths will never be labeled perfect. We either use the designation major or minor for those. So with this in mind, what I'd like to do is show you some examples back to our trusty key A major, which is what we were working in for major and minor, to show you how you can derive perfect intervals from the major scale. The short answer is they work just like major intervals. You can derive any perfect interval from a major scale, given that the lower note is tonic of the scale. Let me show you how this works. Recall there is our A major scale. Now I'd like to show you how we can derive the perfect intervals from this scale. So to start, if we have A to A, the same exact note, that's the easiest interval to identify, and that is considered our perfect unison, which we label like that, capital P and a 1. Let's go on and find the perfect octave. This one also goes from tonic to tonic, except now there is an octave in between the two. They sound very similar, have a very special relationship, and we call that the perfect octave. All right, now let's find the perfect fourth and perfect fifth from this scale. Check out scale degree 1 to scale degree 4 will give us our perfect fourth. In this case, A to D. And then let's find that perfect fifth. Now A to E. And that's our perfect fifth derived from the A major scale. In sum, you can derive any perfect interval from a major scale given the lower note is tonic of the scale. It's the same way we found major intervals. Let's try a few now with a different starting note. Let's say I want a perfect fourth with D as the starting note. How would we go about finding this? Well, if D is the lower note, we want to think temporarily in the D major scale. And all we really need to do is to count the scale up to the fourth scale degree. Whole, whole, half. I can stop there because I've got 1, 2, 3, 4. Therefore, our perfect fourth is going to be D to G. We do not need to add any accidentals to the G because it naturally exists in the D major scale. Let's try another example. Okay, I'd like another perfect fourth, but now I would like my lower note to be F. So what do? We think in the key of F major. All we need to do is get the first 4 scale degrees of the F major scale, and we'll have ourselves a perfect fourth. So let's do that. Whole, whole, half. Therefore, our perfect fourth is going to be F to B flat. Here, we need to use a flat symbol to show that the top note is B flat. Why? Because B flat exists in the scale of F major, and F is our lower note of the interval. Let's try one more. This time I want a perfect fifth, and the lower note is going to be E. So we'll use a similar process, but instead of stopping at scale degree 4 of the E scale, we are going to stop at scale degree 5. Whole, whole, half, whole. That gets us to scale degree 5. Therefore, our perfect fifth is E to B. Why? Because B is scale degree 5 in the key of E major, and we derive any perfect interval from the major scale given the lower note is tonic of the scale. And a quick note about interval inversion. Seconds again invert to sevenths, and thirds invert to sixths. Remember that magic number 9? Well, fourths invert to fifths, and fifths invert to fourths. Again, the magic number 9. Let me show you how that works. Recall that A to D is a perfect fourth. Why? Because D is scale degree 4 in the A major scale, and A is the lower note of the interval. Check this out. If I invert the interval, we get a perfect fifth. Just by taking that low A and putting it on top. Why would that be a perfect fifth? Because A is scale degree 5 in the D major scale. So the takeaway here is that any perfect interval inverts to another perfect interval, and fourths invert to fifths, and fifths invert to fourths. So that's another great way to use interval inversion when working with fourths and fifths.